Good afternoon, everyone. Welcome to live class. So, in the last week, we started chapter number 10 circles, and we are continuing that. So, what are the points we have discussed in the last week? The introduction part of the circle, and also we have completed exercise 10.1. Now we are moving to the next topic, angle subtended by a chord at a point. Angle subtended by a chord at a point. See, so what we have discussed chord definition, so just we have to recollect that. So this AB is there, now we can call it as a chord. AB is the chord of this circle. Okay, so I will write the three most important points in this angle subtended by a chord at a point. Listen, just I'm explaining now. Angle subtended by a chord at a point. The first one, take a listen. Take a line segment. Take a line segment. Just I'm calling that line segment AB. In bracket, you can call it as a chord. As a chord AB, because it has two end points and a point C on the circle, and a point C on the circle. Can you see here? Point C on the circle. Point C on the circle. So exactly on the circle I written that. On the circle with center O. So we have with center O. So what I written the first one? Take a line segment AB. Just I took line segment AB already that, and a point C on the circle with the center O. With center O. With center O. Yes. The next, join AC and BC. The next point, join is already joined AC and BC. See, angle subtended. Just so when you will join AC and BC and will get an angle, that is called as angle subtended. Yes, so we are making an angle here. That third point, AB is a chord and angle ACB is the angle subtended by the chord. AB is a chord and angle ACB is the angle subtended subtended by the chord AB. By the chord AB. See, AB is a chord. This AB is a chord, and angle ACB is the angle subtended, because angle. So we are framing that angle ACB subtended by the chord AB. So by the chord AB, so we are subtending this angle ACB, or also you can call simply angle Y. Also that. Okay. And next, also the last point. Also, listen here. Angle AOB is angle subtended. Also, angle AOB is angle subtended by chord AB. Angle is angle subtended by chord AB at the center. At the center. So you can say that is O. See, this chord AB. So we are focusing or discussing on that angle subtended by a chord at a point. So at the point C and at the point O, angle subtended. The first one, take a line segment. Take a line segment AB, that is chord, and a point C on the circle with center O. So we have to construct one circle and we have to take a AB and the point C on the circle. And the next step, so we have to join AC and BC. Then we'll get it one subtended angle, that is angle ACB. And also at the center. So when you join OA and OB, so then we will get it one more angle subtended by this chord at the center. O. Is it clear? And this is the very important that. Just to see once that. Have a look on that systematically. So what are the points we have written on that? Okay. And now we are moving to the theorem 10.1. Yes. Is it clear? Okay. We'll move the next part. So that is theorem 10.1. Angle subtended by a chord at a point. The next is theorem 10.1. Theorem 10.1. Theorem 10.1 statement I will write it first. Yes, in this theorem 10.1, so what we have, listen here, first we will write it. Equal chords of a circle equal chords of a circle subtend equal angles subtend equal angles at the center. At the center. First I will go for the diagram. Yes. And you are also having that geometry materials, then you can go for to draw, like you can measure 3 centimeter. Wait 1 minute. So I will draw one more. Okay, fine. At the center. Okay, so we'll complete the diagram. See, equal chords of a circle subtend equal angles at the center. So one by one, I am explaining here that So this is the diagram for theorem 10 point. This is O and this is AB. AB. The next one CD. CD. Okay. So now we have to start writing one by one. Listen. The first given we have to write it. See what it is given in the question. We have to read it. Statement we have to read it. It is nothing but theorem 10.1 statement. Equal chords of a circle subtend equal angles at the center. So the first one, two equal chords AB and CD of a circle with center O. So what I will write it? Two equal chords. See, equal chords of a circle they said in the statement. That's why I'm writing two equal chords AB and CD of a circle with center O. Of a circle with center O. Circle with center O. Yes. So in the bracket you can write it. That is AB is equal to CD. They given this. This AB is equal to this CD is given. Got it? The next is RTP required to prove. What they asked to prove here? Yes. Listen. They asked to prove here. So angle AOB is equal to angle COD. So what we have to prove? Angle AOB is equal to angle COD. That we have to prove here. The next one is proof. Yes. Listen here. In triangles AOB and COD. Yes. Can I write it? OA is equal to OD. This OA is equal to OD because radii of the same circle. Radii. Yes, radius plural form is radii of a circle. Instead of mentioning that same circle, of a circle means the one circle. Next, OB is equal to OC. That is also same. You can write it. Radii of a circle. Next, so what it is given? AB is equal to CD. You can write it given. That's enough. Therefore, next you can write it here. Therefore, triangle AOB is congruent to triangle COD by what? In the last class, I explained about, in the previous classes, I explained about triangles. This congruence of triangles. So here, side, and this side by SSS rule. By SSS rule. So you can write it. Therefore, angle AOB is equal to angle COD by CPCT. Corresponding parts of congruent triangles are equal. Yes, and each and every class is very important. That's why we will say that. So you must attend all the classes, because so what are the theorems we are solving in the 10.1 and what we taught in the triangle chapters? Those are the we are writing taking as a basic concept, and we are explaining the theorem 10.1. Just you see that theorem 10.1, because exercise 10.2 both the questions are these two theorems. In the theorem 10.1 I did the theorem 10.2. Is it clear? See once. Okay, we'll move to the next one. Okay, now notes in this. Just you see the steps once. Just I will remove the diagram. Just you go through all the steps. Now I am moving to the theorem 10.2. So theorem 10.2, first I will draw the diagram. The converse of this. One minute, I will draw one more time. Okay, this is fine. Listen here. Here also same. So we have to construct that what we have in the first one. O, the next PQRS, RS. Okay. So we'll see the first we will write the statement, then we will see what we have to take out from the statement. Just I am removing that all parts. Converse of this theorem 10 point. Theorem 10.1. So that is theorem 10.2. Listen, if the angle subtended by the chord, if the angle subtended by the chord, the angle subtended by the chord of a circle at the centers are equal, chords, not a chord, chords of a circle at the center are equal, then the chords are equal, So we have to prove this one. Listen here. The next, what I will write it. Listen. So here they given these two angles are equal. So we have to prove here PQ is equal to RS. So what we have to prove there? PQ is equal to RS we have to prove. So previous one, these two PQ and RS are equal, and we proved this angle POQ and angle ROS are equal. So converse of the theorem 10.1. So first I will write it given. So just what I'm writing given. So what it is there in that statement that I'm writing. Two chords PQ and RS of a circle in which two chords PQ and RS of a circle in which angle POQ is equal to angle ROS. They given this in which. So the next one, to prove. So that I will write it required to prove, RTP always. Yes. So in this required to prove, what we have to write it? PQ is equal to RS. Here, PQ is equal to RS. The next is proof. In this proof, listen here. In triangle, can I write it? POQ and triangle ROS. So once again, OP is equal to OS. We can write it radii of a circle. Nothing but same circle are equal in measure. Radii of the same circle are equal in measure. If this is 5 centimeter, means this it must measure 5 centimeter. Radii of the same circle. Listen. The next one. OQ is equal to OR. So that is also radii of a circle. Radii of a circle. The next continuation I am writing here. The next continuation I am writing here. So they given which angle POQ is equal to angle ROS. ROS. In the bracket you write given. Now therefore triangle POQ is congruent to triangle ROS. See, when two triangles are congruent, the corresponding parts of congruent triangles are equal. Yes, these two triangles, this one triangle and this one triangle. When this triangle POQ is congruent to triangle ROS, the corresponding parts of congruent triangles are equal. So triangle POQ is congruent to triangle ROS. So these are the steps we written. See, side OA, OP and OS are equal, and this OQ and OR. So these two sides and included angle. Two sides and included angle. Here also two sides, one included angle. So what you have to write it? By which rule? SAS rule. Side angle side rule. So hence you can write it. PQ is equal to RS, corresponding parts of congruent triangles. CPCT. Yes, by CPCT, the PQ is equal to PR, and hence chords are equal. Hence, chords are equal. Okay, so we have completed theorem 10.2 and 10.1. Slowly we will move to the exercise 10.2. Yes. So in the exercise 10.2, listen here. So in the exercise 10.2, what we solved in the theorem 10.1 and in 10.2, those same based on one example related to theorem 10.1 and one example is related to theorem 10.2. Yes. So we'll see those two examples. It is clear. If the angle subtended by a chords of a circle at center are equal, then the chords are equal. Then the chords, this PQ and RS are equal. We proved that. So just I will remove this diagram. Okay. So we will go with exercise. Exercise 10.1. In that, question number 1, diagram I will draw it. This is first circle. This is second circle. Point O, center point. This I will take it as O dash. Two circles. One is O and another one is O dash. Okay. Then I will complete the diagram first. So you also complete the diagram. If you are sitting with notebook, with compass, just to complete this diagram. The next is AB PQ. Now I will remove this theorem 10.2 completely. Okay. Okay. The next. See here. First, I will read the question 10 exercise 10.2. First question with the help of NCERT textbook. Recall that two circles are congruent. Two circles are congruent if they have the same radii. Recall that two circles are congruent if they have same radii. Prove that equal chords of a congruent circles subtends equal angles at the center. So equal angles at the center, so we have to prove here. This in this one. Listen. In this one, what we have to prove? Angle AOB is equal to angle PO dash Q. So that we have to prove here. Listen, one by one I will write it. First given. So before that, I have to write it question number 1 this. Question number 1. Exercise 10 point, not 1, I'm sorry, 10.2. Question number 10.2. Question number, sorry, exercise 10.2, question number 1. Two circles with equal radii. Two circles with same radii or equal radii. Equal radii and with center O and with centers O and O dash. Two are there, two centers are O and O dash. And also you can write it in the bracket here. In the question itself they given here AB is equal to PQ. Yes, AB is equal to PQ they given. Now we have to write it RTP. Same as it is. So what we have the theorem 10.1. In the theorem 10.1 and this example, so what is the difference? So we done it theorem 10.1 in a circle and we are considering two congruent circles. Yes, two congruent circles we are considering that. So two circle with the equal radii is nothing but congruent circles. Next, to prove angle AOB is equal to angle PO dash Q. So the next is proof. In triangles AOB and PO dash Q. What I am considering triangle AOB and PO dash Q. These two triangles I am considering. Next, OA is equal to O dash P. Then OB is equal to O dash Q. You can write it at a time. Radii of a circle. Yes, radii of the circle you write, not same circle because congruence of circles. Or you simply can write it in the bracket. So equal congruence is there. So just better you write it here. Radii. That is more than enough. AB is equal to PQ. That is given. So therefore, triangle AOB is congruent to triangle PO dash Q by SSS rule. By SS rule. So you can write it at last. Therefore, angle AOB is equal to angle PO dash Q by CPC. Corresponding parts of congruent triangles. The first one we completed. So we are moving to the second one. The second one, the diagram is same. So just you see once this. Yes, is it clear? Just I will move to the second one in this. Number 2. Okay. Just I will change the here numbers. The diagram is same. Okay. So next what I will write it, listen here. ACB PRQ. Instead of that I am taking here. Okay. Just I will remove the question number 1 in the exercise 10.2. So just I am moving to the question number the next. Okay. See, two congruent circles in which here they given these two circles are equal. Sorry, these two angles are equal. So we have to prove here AB is equal to PQ. Listen, I will read the question first. Listen, children. So I will read the question in the page number 173, exercise 10.2, second question. Prove that if chords of a congruent circle subtend equal angles at their center, then the chords are equal. Okay. Just first, I will write it. Two congruent circles. What I am writing in the given. Two congruent circles. Question number 2. Two congruent circles in which what we have to write it. Angle ACB is equal to angle PRQ. These two angles ACB is equal to PRQ. Yes. So required to prove that is AB is equal to PQ. This AB is equal to PQ. Required to prove. So in the proof, in triangle ACB and in triangle PRQ, because these two circles are congruent. Yes, congruent means, so what the radius it will measure AC, the same radius it will measure with PR, the next radius of the circle. Okay. So next what I am writing, you see that AC is equal to RP or PR also you can write it, but I will write it in the order wise. PR radii of the congruent circles. Next, BC is equal to QR. That is also you can write it radii. The next one, listen here. They given angle ACB is equal to angle PRQ. Yes, that you have to write it given. Okay. Therefore, I will write it here. Therefore, triangle ACB is congruent to triangle PRQ by CPCT. Corresponding parts are from. Sorry. So we have to write it here by which rule? By which rule? Listen here. Side angle by SAS. By SAS rule. So hence we can write it AB is equal to PQ. Hence we prove this. Yes, we can write it reason also here. So what you will write it reason? Corresponding parts are congruent triangles. AB is equal to PQ by CPCT. Okay, thank you so much. That's all of today's class, and remaining part we'll study in the next class tomorrow. Thank you.